Myself, Dr. Chandrabhushan Pal, FDP Coordinator and Associate Professor in Chemical Engineering Department, SN Patel Institute of Technology and Research Center, Umrang, Badoli, Surat. It is my privilege to introduce our esteemed speaker, Dr. Sachin Sir, who has graciously accepted our invitation to be with us today. Dr. Sachin Sir is a professor and former head of Department of Chemical Engineering at VNIT Nagpur. He holds a BTech, ME and PhD from Lakshmi Narayan Institute of Technology, LIT. Dr. Sachin Sir currently serves as the chairman of the Board of Governors at Government College of Engineering, Amravati. He is also an academic council member of Dr. Baba Saheb Ambedkar Technological University, Nonle, and he was the governor's nominee to Yashwantrao Chauhan Maharashtra Open University, Nasik. Also, his research expertise span biomass and waste utilization, biorefinery, sustainable engineering, and scientific validation of traditional sciences. He has authored 130 plus publications, accumulating 4,800 plus citations with an H index of 33. He has successfully supervised more than 10 PhD scholars and holds 12 patents also. Dr. Sachin sir has led R&D project worth rupees 5.5 crore funded by government agencies and 2 crore from industry collaboration. Recently, the Department of Science and Technology (DST) awarded him a Center of Excellence on Agricultural Waste Utilization worth 12 crore rupees. A fellow of Maharashtra Academy of Science, Dr. Sachin sir received prestigious Sri Ramakrishna Paramhans grant for translations research in agriculture in 2023. His contribution to industrial applications include designing and commissioning the world's first potato field biorefinery plant. Let's give a warm welcome to Dr. Sachin Mandavgane sir and hand over this session to Sachin sir. Thank you.
Thank you for introduction, and I apologize that my somehow my video is not working. So I will now start sharing my screen and allow. Uh, yes. So Pal sir, you just please give me background of participants. Are they all engineering? Whether what are the background of participants in general? Am I audible? Am I audible?
Yeah, yes, sir.
Yeah.
Hello.
So yeah, sir, you please just
Sir,
give me some background of the participants.
participants belong to the engineering colleges, researchers, and industry persons also.
But are they all engineers or there are some science people also?
They all are some are from science field also, agriculture field also, food fields also, and pharmacy also.
Okay, fair enough. Okay. So my screen is visible right now.
Yes, sir.
Yes.
Okay. So thanks to the organizers and coordinators of this ATAL FDP, and the topic which has been assigned to me is green chemistry, sustainable agriculture, and processing system. As far as the green chemistry is concerned, this very word was coined in 1987, and it was realized. And then the second word, sustainability, was also coined somewhere in late 90s, where it was realized that sustainability has different shades. Sustainability from agricultural perspective, sustainability from urban living, sustainability from typically climate change and climate processing, climate action plans. And so these are the terms which were introduced for the first time. These words were coined somewhere in 1987 or later than that. And in last decade, this has become a very important topic. Earlier, it was more of a fashion, it was a buzzword, but in last 10 years and very specifically around COVID, last 5 to 6 years, sustainability has become extremely vital thing. SEBI, who regulates the Bombay Stock Exchange, uh, in around 3 4 years before, they made it compulsory for all industries, top 1000 listed stock exchange industries, to fill up BRSR. BRSR is business responsibility and sustainability practices, one format, and that format has to be filled. It has been made mandatory for the top 1000 industries who are listed in Bombay Stock Exchange. And once it has been made mandatory to 1000 industries, obviously it will be made mandatory to other industries in coming future as well. And so my my presentation will be around couple of case studies related to sustainable agriculture, and how green chemistry part has been introduced. So there are green chemistry principles, there are green engineering principles. These principles are available in the public domain. So I would request you that sometime you please just browse and find out what are all the green chemistry principles. Very obvious principles now. If there are a participant from chemistry background, they will find it very common. Use of catalyst, improving atomic efficiency, reduction of waste, then resource efficiency, recycling, reuse. So these are the things, but typically from chemistry point of view, a lot of emphasis is given on solvent, use of solvents which are non-hazardous, then alternative raw materials. So having a raw material from resources other than fossil fuel based or fossil, I mean typically other than crude oil, then how can I minimize the waste, or can I reuse the waste for some other purposes. So these are typical green chemistry principles, and a lot of work is being done on green chemistry, green engineering. And one more thing which is being lately introduced in chemical engineering is about process intensification, right? So but the focus would be more around sustainable agriculture. That is what I'm going to talk about, and not the agricultural practices, but how agricultural feedstock, raw material, agricultural residue can be used for processing and producing products which are otherwise being produced using fossil fuel, using crude oil. So we want to have same set of products which we are producing from crude oil, but instead of producing from crude oil, can we produce same from biomass or agricultural residue? That's the idea. And so couple of just to create a background and to understand, to make you understand the importance of biomass and agricultural residue in India. Around 86% of the land in India is owned by small and marginal farmer. Small and marginal farmer are those who are having land holding less than 2 hectares. 2 hectares means around 5 acres of land. And India produces, this is only for North India, the data which has been published for Punjab and Haryana, it says that 50 million metric ton of agricultural residue is produced in Haryana and Punjab. So obviously, see, the general understanding is, the last point is about per kg of grain that is being produced, almost equal amount of straw and stack, that is agricultural residue, is produced. So FDA has spell out how much is the production of grains in India, right? So whatever the amount of grains that we are producing, same amount, almost the same amount of agricultural residue we are producing. Then horticulture, like fruit, vegetable, flowers, it is reported that 30% goes waste. It's a reported literature. Now, what are the things that we require and to for our daily life? These are the societal needs. We require energy. We require energy in the form of electricity, heat, transportation, fuel, and we require organic chemicals. Life, we cannot imagine life without organic chemicals and polymers. Some of you might be attending this session through mobile, maybe laptop, maybe desktop, right? So these are the things, or television. You have two wheelers, even the car bodies, helmet. These are all polymers, different energy engineering polymers, right? So at this moment, more than 80% of energy and 90% of organic chemicals in the world are derived from fossil fuel alone. So what we are aiming to do is, we want energy, we want organic chemicals, we want polymers. That's the essential need. But instead of deriving it from fossil fuel, can I derive it from agricultural residue? That's the whole idea, that's the whole concept. So why we want to do that? One, of course, the crude is limited stock. It will deplete over a period of time. We have to depend on outside countries and import it, right? So these are couple of things which, and moreover, the GHG emission, carbon dioxide emission, those are the inherent part of it. On other side, we have the small and marginal farmers. They get money for their grain, whereas they produce equal amount of agricultural residue, which otherwise goes waste. Can we create value from the waste? Can we have similar products like energy, organic chemicals, and polymers from the agricultural residue? So that the farmer will get some additional money, right? May not be doubling the farmer, but some additional money from the produce which he or she cannot sell in the market. He can sell rice grain, he can sell wheat grain, but he cannot sell straw and stack, right? At a promising price. So therefore, what I'm going to share with you is new agricultural business models where we can use these agricultural residues to produce the same products which we are otherwise producing using crude oil. And that gives birth to the concept called biorefinery. And biorefinery is quite analogous to petroleum refinery. What is done in case of refinery is that we have one raw material, and from one raw material we make arrays of products like gasoline. Gasoline means petrol, diesel, from the single raw material, that is crude oil. From the single raw material crude oil, these are the arrays, this is the set of raw products which are produced in a refinery. But the starting point is crude oil. Now, our idea is, instead of crude oil, let us use bio feedstock and produce biochemicals, produce biofuels, and any specialty product, typically high value product. So biorefinery is a sequential extraction of valuable products, and instead of producing any single you producing in single product, make let us have integrated approach for multiple products. Use of grass. I'm going to talk about the different classification of biofeed stocks, typically grass, agricultural residue, peels and seeds. And the advantage is it is renewable in nature and has lesser environmental impact. And obviously it offers opportunity for additional revenue to the farmers, circular economy. This is important. These are next slide. Those who are from chemistry and maybe from energy background, maybe from chemical engineering background, they will appreciate and understand what I'm talking about. The energy crops. So typically grasses, different types of grasses are called as energy crop. and these energy crops are cultivated mainly as feedstock for anaerobic digestion. So one category is energy crop. This is for biomass. Second is agricultural residue, typically stock, like the area region from where I am now talking. I am talking from Nagpur. Ours is the belt of cotton. Look at Bardoli and the area around, lot of groundnut. So groundnut shell, soybean stock. Because once soybean is plucked and removed, the leftover stem is a agricultural residue. Then you have sugarcane trash. You can have rice husk, rice straw. So that all this all falls under agricultural residue. Then the forestry waste. The forestry waste is biomass resulting from forest management operations, and industrial waste, the food processing and waste paper. So I'm going to talk about food processing waste. I'm going to talk about the agricultural residue. From typically constituents point of view, these are three categories. The one category, the first category is triglyceride based. When you have vegetable oil, animal fats like this, sugar based. You have sugar beet, sweet sorghum, sugar cane, where the raw materials are mainly starchy or they contain sugar. And the third category is lignocellulosic feedstock. Now, this is very interesting and important. We have seen that petroleum refinery, we have like you have Bharuch, a lot of petroleum refineries are in and around Surat and Gujarat and the coastal part of Gujarat, maybe Jamnagar and that area. The what this petroleum refinery do are following. They produce platform chemicals. Platform chemicals are those which are the building blocks, and using that we can make different products which will meet our energy need, our organic chemical need, our fuel need, as well as the polymer need. So what they do is they produce syngas. The syngas is typically carbon monoxide, CH4, hydrogen. Then the olefins, these are unsaturated hydrocarbons, double bonds. Ethylene, 2 carbon, propylene, 3 carbon, butadiene, 4 carbon, uh, double bond, and it's a unsaturated hydrocarbon. So then third category is ring structure, that is benzene, toluene, xylene. These are typically aromatic compounds. So we get the small compound like hydrogen carbon monoxide, we get ethylene, propylene, unsaturated hydrocarbon, straight chain, and ring kind of structure like benzene and toluene. Using these are the platform chemicals, and using this, typically the polymers. Maybe if I have ethylene, so I can have a polyethylene, polypropylene, right? So this is how the polymers are produced. Organic chemicals are produced. So these are the building blocks, and these are the main products of any petroleum refinery. Now, what the idea is to have a platform chemicals using the biomass, that is from biorefinery. And these are typically, there are 13, somewhere they write 11, 12, but these are typically, this is the list of platform chemicals from a biorefinery. You can get this information well available in the public domain. Now what we do, so this is the background. Last 10-15 minutes I was just talking about the background of sustainability, background of what is the need at present, and from where we are producing fuels, chemicals, polymers right now, right? Now what, now the rest of the talk is all about the experiences and the work that we do here at VNIT Nagpur Chemical Department. And we are working on paddy straw, we are working on cotton stalk, we are working on sugarcane trash, and we call it as a brown agricultural residue. Then we are working on green agricultural residue, that is the horticulture waste. What I mean by horticulture waste is potato waste, Then orange waste, because Nagpur is known for oranges. Again, 30 to 40% oranges go waste. So we are creating value from that. And the third is about the biomass fuel which is being used in the industry, the waste which is generated, how to make use of it. So I will go one by one, the short videos in between. So we start with the biomass. I think the cursor might, let me see whether the cursor, oh shit, no. Anyway, I'm talking about from the farmer we get this biomass, typically paddy straw. Focus is paddy straw. We do lab level processing, so basic engineering, basic work, so that we can understand the chemistry, we understand the process, we develop the process at lab level. Once the lab level work is done, we found that the products that we are producing, they either go in three variants. One is agriculture inputs, second is veterinary inputs, and third is the food supplements. Once we do these trials on the field, then we go for scaling up. We have good industrial partners. I'm going to share with you how we have produced different products and taken up to the industry level. These are a couple of so this is what I'm going to talk about the let me show you one interesting video, then I will go back. Sometime back, you might have come across potatoes, and typically a government has an initiative called tomato, onion, potato. They call it as Mission Top. And under Mission Top, we propose that we will create value from potatoes, waste potatoes. So Merino Industry is our industrial partner. Merino is in Hapur, in NCR. They are in potato processing, as well as they are in contract farming of potatoes. So their main product is potato flex, and the first stage in potato processing is cleaning the potato and peeling the potato. As far as the peeling is concerned, the peeling is done by two methods. One method is what we do at home, typical mechanical abrasion. Second is expose these potatoes to high pressure steam momentarily. When we expose it to the steam momentarily, the outer skin of the potato become loosened, and then the potatoes are passed through brushes so that the peeling takes place. Now, the peel has some starch adhere to it. So that is our starting point. The waste which is generated from the peeling unit of potato processing plant is our starting point. From that, what we have done is we have produced these products: nutraceutical, dietary fiber, prebiotic, biogas, and compost. Peel and attach starch is first dislodged. The starch is sent for anaerobic digestion to produce biogas, and the leftover slurry after biogas is produced is used for compost. The peel, the skin, the outermost extremely thin layer is a rich source of nutraceutical. We are extracting those polyphenols, making capsules of nutraceutical, and the dietary fibers are rich source of prebiotic being used in poultry. I'm now going to show you the actual video. See, this is wait, yeah, this is the oops, the pilot plant, the where the hydrolysis is taking place. Here the peel and starch material is removed. This is the peel. This is white water is starch which goes to anaerobic digestion. The peel is dried. From this peel we extract polyphenols and dietary fiber. And we have work on oranges, apple, pomegranate, tomato, onion, mango. Almost all we work at VNIT. And I'm going to show you another video about oranges as well. Right? Yeah. Now coming back to what we do with fruit and vegetable. Now since you have seen potatoes, we are developing edible coatings. We are developing dietary fibers which are soluble, sometimes they are insoluble, producing nutraceutical. By fermentation, we are getting enzymes, compost. I'm going to talk about enzymes as well. And those enzymes are useful in biogas, enzymes are useful in fodder as well. Right? So using the fruit and vegetable waste, these are the different products which are being produced. Yeah. Uh, those from chemistry, chemical engineering, separation, they will appreciate what these papers are. These are about selective separation of polyphenols from the potato peel. And we are selectively separating, we are using the mixed culture, mixed mixtures, I mean mixture of polyphenols as well. Sometimes we are extracting based on the requirement. And the last one is dietary fiber extracted from potato processing industry waste are a good prebiotic. That is what I was talking about. Now this is second case study is about orange biorefinery. Again, this part of India is known for oranges. Nagpur oranges are having GI tag. GI tag means geographical indicator. It is because of the soil condition and the climate condition, the oranges which are produced here, they are having a typical flavor and typical taste. So Nagpur oranges, like we have this Darjeeling tea. So the name of the city, name of the location and the product, they are generally pronounced together. It is called as a GI tag product. Here, we found that Nagpur oranges are typically grown in the region of Nagpur and Amravati region. And again, 40-50% goes west. We want to create value from these oranges. So we targeted on the skin of the orange. You might be knowing that the orange skin has oil. So we develop a method of extraction of oil from the skin. And we develop a method of extracting dietary fibers, as well as the leftover part is used for making compost. I'll show you this short video. So we are now trying to have a dedicated BIS standard for Nagpur Orange Oil. Right? Fine. So a lot of chemistry is involved, green chemistry is involved. I mean, I'm not going into detail of the chemistry part because the audience is quite mixed. Somebody is interested, our papers are published. I can share information as well. In Nagpur orange oil, essential oil, again we use it into broiler feed, chickens, and the results are very good. Paper is already published. And the soluble dietary fiber from orange peel, good properties when they are put into dairy products. Fine. So that was a part about green biorefinery where we are using fruit and vegetable waste. So now I'm going to talk about brown biorefinery when we will be using typically paddy straw and cotton straw kind of material for creating value. Here biomass is shredded, is mixed with culture. We have here at VNIT develop a patented culture Bajrang Band, and this culture is extremely potent. And using that on-farm enzyme is produced, and use this enzyme is further used for uh, accelerating the overall composting process, which otherwise take 3 months time. And 90 days, we brought it back to from 3 months, we reduced it to 3 weeks. And even we work with NDDB and Nagpur, Maharashtra's Veterinary University to convert dry fodder into nutrient-rich fodder and biogas. I'm going to show all these are having short videos, so you will understand it. This is the work that we have done at Merino Industry Hapur, and they are right now producing 2 tons of compost using paddy straw. So paddy straw has a very high carbon to nitrogen ratio. The meaning of high carbon to nitrogen ratio is it has it degrades extremely slowly. If you go to North India, if you go to typically maybe or East India, West Bengal, Orissa, you will see that there are hutments which are made using paddy straws. It only means that these paddies do not get degraded even when they are exposed to extreme weather condition and continuous rain, something like that. Reason is it has very high carbon to nitrogen ratio. So what we have done is we develop a culture which rapidly decreases the carbon to nitrogen ratio above 50 to below 25. And better listen to this video. This is a very comprehensive video. right? Fine. Now, uh, yeah. Then using the look at this slide. Here I have shown you that we have developed enzymes, right? And these enzymes, when used in composting, typically we require 3 weeks time for composting. Maybe you take 30 days. Either 20 or 25 days are required. 5 days additional we keep it as a buffer if it is cold, and then maybe it requires a little more time. Not more than 30 days for sure. But if we use enzyme which we have extracted from the Bajrang Band, the entire process is completed in less than 2 weeks time, right? This is for those who understand and appreciate the biochemistry of it. You'll see that number of x-axis is number of days and C/N ratio on y-axis, and T1 is about batch, typically using Bajrang Band, and Bajrang Band, and T2 is using enzyme. So in enzyme, the C/N ratio drops down very fast. This is the structure. This is the manufacturing unit of compost in Merino. Based on this, CII Foundation also took some initiative. They have this plant shade at Sirsa, Haryana. They would be having another at Barnala in Punjab. Then same enzyme when used for pre-treatment of paddy straw and to produce biogas. We found that if shredded paddy straw is treated with enzyme, that it has a property, it has a property quite similar to cow dung. So we call it as artificial dung. And so the artificial dung is nothing but enzyme treated paddy straw. The COD, then C/N ratio, volatile solids (VS) of cow dung and enzyme treated paddy straw, they remain quite similar. And these are the trials which are going on in a Dinbandhu model of gobar gas, 6 meter cube. And this is the optimized ratio: 75 uh, kgs of paddy dung. Paddy dung means artificial dung, that is enzyme treated paddy straw, and 50 kgs of cow dung. And we found that if I use 125, maybe typically if I use 100 kgs of cow dung, I repeat, if I use 100 kg of cow dung, generally the gas produced is 4 meter cube. So if I'm using 125 kgs of cow dung, I will produce 5 meter cube of gas. Here, typically, this 125 kgs, which is a feed, is a combination of 75 kgs of paddy dung and 50 kgs of cow dung. We are on an average producing gas that is 8 meter cube, which is significantly high. Not only higher gas that we are producing higher methane also. So the methane production is not less than 65%. So enzyme that is produced from Bajrang Band is accelerating compost. Not only so, it is giving me enriched and more biogas if it is used in case of a biogas. And third is about fodder. I'm going to show you a short video and then I will come back up again. It is all about fodder in India. Typically, you in Gujarat, also everywhere is a scarcity of dry fodder. Watch this video and then I will discuss about this. right? So this is what is given about. This is all covered in the video. How the trials on gear were conducted, how the trials on goat were conducted. Yeah, this is the pricing. Typically, pricing is 60 to 70 paise per kg of agri waste that is treated Bajrang Band. If you want to extract, if you extract enzyme, and if it is produced on the farm based on labor and the resources which are available on the farm, the cost varies somewhere from 5 rupees to 8 rupees per liter. And cost of base compost, so we have two compost. Base compost is the one where it merely meets the basic requirement of calling it as a compost, like C by N ratio is less than 20, then the pH should be around 6 to 6, between 6 to 8, electric conductivity less than 4. So that is our base compost. Then we go for the fortified compost. So fortified compost is the one which is enriched with maybe potash, maybe some microbes, plant growth components, something like that. And when we are using this enzyme for biogas, the HRT is drastically reduced. And typically conventional is 25 to 30, sometimes it goes even 40 to 50 also. Whereas in our case, it is 15 days, maybe maximum 20 days. in when we are using for enzyme treated fodder, and we are feeding it to cattle's, milk yield is increased. Generally, when the milk yield is increased, it is at the cost of fat. But in our case, the milk is also increased, fat is also increased. This is what general cost benefit value proposition based on the culture that is being developed and the enzyme which is extracted from the culture. And now biomass, like biomass briquettes, are extensively used in industries as a fuel. Ash is produced, and using this ash, we develop a method of extracting biopotash. Let me tell you, India is 100% dependent on outside countries for their potash requirement, and we import potash. Uh, so, so the Prime Minister's Scientific Advisor's Office sometime back has asked that can we have some method of extracting potash within our country, right? This is a method. Yeah, watch this. So this is the project which was funded by BRNS. We completed it, and paper related to that are all available in the public domain. This is what we do as a theoretical part, life cycle assessment, techno-economical assessment. So the different processes that is being developed. For every process, it is generally expected that we need to know the environmental impact using LCA approach and the techno-economical analysis. So recently, this is what Department of Science and Technology has awarded us a Center of Excellence to work on agricultural residue. We call it as SWAHA. So the SWAHA stands for Sustainability Assessment. So this is what the center does: sustainability assessment, waste valorization, agricultural inputs, health supplements, and awareness and training. So with us, we have MAPSU, that is Maharashtra Animal and Veterinary University. Then IIM Nagpur, AIMS Nagpur, IARI Delhi, Merino is our industrial partner, JNU, the Science Policy Center, and the NGO. So we could do all these things because of my scholars and funding agencies, industrial partners. Otherwise, doing actual field work is very difficult. Thank you. I'm done. If you have any doubt, question, you are free to ask me.
Participants, if you have any questions or query, please ask to the Sachin sir. Or drop your questions in chat box also.
Meanwhile, I have a question for all that if you can submit this information, your place and agricultural residue available in your place.
Hmm? Quick, no question. Sorry. Uh, okay. Thank you very much, sir. Uh, today's sessions, we are able to understand very important topic like a green biorefinery approach. Another one is the extraction of hydroxybenzoic acid from potato processing industry waste, and also orange biorefinery, pre-treatment of paddy straw with enzyme treated. And Sachin sir also saw the innovative research work at Marino Invention Center, and this one of the most important valorization of biomass is in char extraction of the biopotash. And sir also provide knowledge as life cycle assessment consultancy to industries and is among the first in India to introduce a credit course on sustainability engineering and innovative design for chemical engineering undergraduate. Thank you very much, sir, for given informative knowledge session to our participants. I hope all participants will be explore knowledge in their research work as well as future work also. Thank you, sir.
Yes.
Sir,
Thank you,
one
and
more
I
question.
request that, see, I have shared this Google form. Nothing is compulsory
Hmm.
in the form, right? Only thing is that I just want to know what are all the different ways which are available, because accidentally we got many information. Like for example, sometime back people told me that in their region they have a chiku as a waste, sapota, and the sapota
Mhm.
seed waste is a big waste in their region. So we started working on that, and then
काय
even custard apple.
हो गाडी आहे काय हो हे सेशन आहे IVDP हो ना काय सोबत तुला पण दिले रे हो काय तुला काय दिलं मी उशिरा पोहोचलो ना त्यामुळे मला दिलं ते सॉफ्ट स्किलच्या वेळेचं नाही हा सॉफ्ट स्किलच्या दिवसात
Hello, sir.
Yes.
One question in the chat box that what precautions should be taken if we want to utilize agricultural waste nanoparticle as absorbent?
Agricultural waste nanoparticles.
Yeah,
Please
they written
explain
in.
more in detail.
Uh, what precautions should be taken if we want to utilize agricultural waste nanoparticle as
No,
absorbent?
I have never come across agricultural waste nanoparticles. If the question, if you can ask, you tell me from where you are getting the nanoparticles from agricultural waste.
Okay. Mhm. होता ही नहीं ना. Sir, one more question. Can we use microorganism also for this process?
In most of the processes, we have used microorganisms. Our processes are mainly biochemical based, where we are using microorganisms. Microorganisms are very important.
Okay. Uh, Sir, we take one group photograph. So please make
Problem is
on.
with my camera. That is what I told initially. मेरा camera ही
Okay.
on नहीं हो रहा है.
Okay, sir. Okay. Not issue. Dear participants, please make on your camera on, and we take one uh, group photograph. Sir, one more question in chat box.
Yes.
Can we industrialize the compost?
Can we?
Industrialize the compost?
I could not understand the question.
आप पूछो।
जिसको पूछना है वो अनम्यूट करके पूछे।
हेलो मिस्टर राहुल सर, डॉक्टर राहुल प्रजापति, प्लीज हेलो हेलो डॉक्टर राहुल प्रजापति, now we are allowed to you to speak. Your mic is now open. Now you can speak. Hello.
या वो क्वेश्चन जो है वो चैट बॉक्स में मुझे चैट बॉक्स में नहीं दिख रहा है क्वेश्चन।
Hello, I'm audible.
Yes,
Now you
yes.
are audible, sir.
Okay, thank you, sir. Sir, I'm also working on the biocomposter to making the various compost from the various bioresources. So my question is that can we industrialize this kind of compost?
What do you mean by industrialize?
Industrialize means that the mass production of this compost, and because for that right now what the
That is
conventional
what
process.
Merino is doing. Merino is right now producing 2 tons per day.
Okay.
So they are producing almost 500 to 600 kg, 600 tons per year. So the process that I have shown about in Merino, that is all industrial scale.
But the problem is that what we are using the compost is the various biomass are there. The thing is that the balancing of the various nutrients, it's quite like impractical to make the balance. So that's why what happened when we go for
What are all the feedstock that you are using?
right now I'm agree food waste is using the feedstock.
Food
But the thing
waste.
is that food waste and some like as agriculture waste also. But the point is that when we compose this, the thing is that it took it first very good time to compose like nearby 8, 9 to 10 days. Second thing is that second thing is that after composting the composting the when we compose the various nutrient what it required to grow the plant sometimes not be able to provide them uh, like for the if I need some phosphorus based compost, so I need to identify the various food waste which is available nearby me, so then I'm able to meet the demand. The point is that collections to distributions, can it be a possible we can generalize the specific nutrient based biomass to the market and
Yeah, I will answer you. First of all, as far as the fruit and food waste is concerned, we are not working on food waste because making compost from food waste contains around 70% moisture. And so our target is agricultural residue which is abundantly available, and the culture and all those things that we suggested is for agricultural residue. That is point one. Second point is, as I spoke during my presentation, something called base compost and the fortified compost. So base compost is where we use some feedstock, produce the feeds, and we comply to FCO. FCO stand for fertilizer control order, and then fortification of it. For fortification, maybe phosphorus rich, maybe potash rich, maybe nitrogen rich as well, right? So then in that case, we have to add those nutrients over and above the base compost. So first of all, we will have to produce base compost, and once the base compost is produced, complying to FCO, when based on the market demand, you need to fortify it. Your NDDP Mruda is also doing same thing.
Okay, sir. Actually, I am designing the right now the compost biocompost reactor, which
Okay.
can use to make the compost continuously. But the thing is that the problem is that when you go for the specific nutrient base, so it has some very good challenges to work on this thing.
So nutrient richness has to be done post base compost is produced. You cannot do it right from the beginning.
Okay. So
Yes.
after the post, we can do the some
Once the
addition of the.
compost is produced, once the base
Hmm.
compost is produced, then you add it.
Okay, sir.
Huh? Okay, yeah, yes.
Thank you.
और किसी का कोई सवाल है?
Okay, sir. Thank you very much, sir,
Thank
for
you.
giving us your busy schedule, time for us from busy schedule. Okay, sir.
Yes, thank you. Thanks a lot.
Okay, sir.
Thank you very much, sir.